So now let us look at the fundamental periods of some very standard functions. So whenever you think of periodic functions, the most notable periodic functions that come into the mind are trigonometric functions. Trigonometric functions are the most famous periodic functions. So if you take sine, cos, tan, cot, cosecant, secant, the fundamental periods of these functions are 2 pi, 2 pi, 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 2 pi, 2 pi. So if you look at the graph of these functions, these periods will be clearly visible to you. These are the segments, length of segments of these graphs which repeat again and again. And if you take modulus to these functions, so mod sin x, mod cos x, mod tan x, mod cot x, mod cosecant x, mod secant x. So if you take mod, all the trigonometric functions has periods of pi. So again, if you look at the graphs of these functions, the period will be very clear to you. And mod sin x plus mod cos x, remember this, has a period of pi by 2. So you can check this. If you find f of x plus pi by 2, you get exactly the same function again. So sin x, mod sin x plus mod cos x has a period of pi by 2. And sin square x has a period of pi. Sin x has a period of 2 pi, but if you square it, you get a period of pi. Sin cube x, if you cube it, if you raise it to an odd power, the period will be same as 2 pi. Similarly, you can think of the periods of cos square x. Cos square x has a period of pi, but cos cube x, if you do odd powers, the period will be 2 pi itself. So these are some standard functions, fundamental periods which you need to remember. And from these, we'll derive the periods of some more complicated functions. So most often, complicated functions are made up of these simple functions. So you need to remember these values. Now let us look at specific properties of periodic functions. So if f of x has a period of t, then 1 by f of x, root f of x, so on, also have a period of t. Because if f of x plus t is equal to f of x, 1 by f of x plus t is 1 by f of x. Root of f of x plus t is root f of x. So if f of x has a period t, 1 by f of x and root f of x also have period of t. The second point, this is the most important point. If f of x has a period of t, if you replace x with ax plus b, the period becomes t by mod a. For example, if sin x has a period of 2 pi, as we know. So what is the period of sin 2x? X is replaced by 2x. So the period of sin 2x will be the period of sin x by 2, that is equal to pi. What is the period of sin of minus 3x by 2 plus pi by 3? Here x is replaced by minus 3 by 2 times x plus some constant. So what is being multiplied with x? Minus 3 by 2. Hence the period is the original period of sin x divided by mod of minus 3 by 2, which is equal to 4 pi by 3. Which is equal to 4 pi by 3. So this is a very useful property. What is the period of fractional part of 3x? Fractional part of x has a period of 1. X is replaced by 3x, so the period is 1 by 3. So this is how you find the periods of f of ax plus b if you know the period of the basic function f of x. Next, if f of x is equal to k, that is, if f of x is a constant function, So a constant function is periodic, but there is no fundamental period, because a constant function satisfies all the properties of periodic function for any value of t, because f of x plus t is equal to f of x for any value of t. Hence, the fundamental period is not defined. And if f of x has a period of t1 and g of x has a period of t2, if you have two functions, one with period t1, other with period t2, then f plus g, fg, f minus g, f by g has a period of LCM of this t1 and t2. For example, if you have fractional part of 2x plus fractional part of 3x, what is the period of this function? The period of the first function is 1 by 2. The period of the next function is 1 by 3. So the period of the effective function is LCM of these two. LCM of these two. Now, this LCM need not be the fundamental period. So whatever LCM you get, it need not be the fundamental period. It need not be the lowest period. You get some value of the period. So taking that as the reference, you can go back, you can go to smaller values of periods and check for the fundamental period. So the LCM, if you do, you get one of the period, but it need not be the fundamental period. So you have to do the further analysis to find the fundamental period. So if LCM does not exist, then the function is non-periodic. Sometimes you might get two numbers such that their LCM do not exist. And for example, if you have one rational number and the other irrational number, you cannot find LCM for a rational number and an irrational number. And LCM of irrational numbers, fractions, can be found out by this formula. The LCM of fractions is LCM of numerators by HCF of denominators. So this can be applied here. So what is the period of this function? The first function has a period half, the second function has a period 1 by 3. So the period of this function is LCM of 1 by 2 and 1 by 3. That is the LCM of numerators, 1 and 1, LCM is 1 divided by HCF of denominators. What is the highest common factor of 2 and 3? 1. That means the period of this function is equal to 1. So if you have fractions, if you want to do the LCM of fractions, the formula that you need to use is LCM of numerators by HCF of denominators. For example, if you have fractional part of x plus sin x, you are asked to find the period of this. The first function has a period of 1. The second function has a period of 2 pi. So the effective function should have a period of the LCM of these two. But 1 is a rational number, but 2 pi is an irrational number. So these two numbers do not have an LCM. Hence, this function, even if it is made up of two periodic functions, is a non-periodic function. So there is no period for this. That means the sum of two periodic functions need not be a periodic function. So the sum of two periodic functions will be a periodic function if and only if the LCM for the corresponding periods can be found out. So they can be all rational, or both of them can be irrational of the same order sometimes. We have sin x plus cos x. So the period of sin x is also 2 pi, the period of cos x is also 2 pi. Hence the LCM of 2 pi and 2 pi is 2 pi. So if you can find the LCM, then the LCM is the period. But again, it need not be the fundamental period. Next, final point, if you have a composite function containing a lot of functions. If the innermost function is a periodic function, then the whole function will be a periodic function. For example, root f of x is also a composite function. What is the innermost function? F of x. If the innermost function is a periodic function, the whole composite function, that is, if you have a log here, log root f of x is also a composite function. Integer part of log root f of x is a periodic function. So on. How many ever functions you apply, if the innermost function is a periodic function with period t, the whole function will also be a periodic function with a period t. Again, it need not be the fundamental period. So once you have a period, you can divide it with successive numbers to see the fundamental period.